Welcome to this maths video brought to you by Upvision Concept Academy. In this video, we'll be looking at logarithms. So, what are logarithms? Logarithms is the power or exponent to which a base must be raised to produce a given number. For example, if b raised to the power x is equal to y, then the log of y to base b is equals to xn raised to the power n. Just think of it as asking, how many times do I multiply a base to give the number? For example, if I have, for instance, log 8 to base 2 is equals to 3. Why? Because I might have to raise 2 to the power of 3 to get 8. That's what log is talking about. So in this video, we'll be looking at the laws of the logarithm, how to change their base, and how to apply it in the equation. Let's go further. I will start by sharing with us the various laws of logarithm. The various laws of logarithm. Laws of logarithm. There are laws that we will need to know, have them in our fingertips, and whenever we see problems or things to solve, we apply those laws. The first law is the product rule. The product rule. The product rule. Okay, so if you have log the product of m and n to base b, if you have log the product of m times n to base b, it is written as log m to base b plus log n to base b. That is the product rule. The product rule states that if the log of two factors, you have two factors multiplying themselves, you can split the factors and take the log of each of them and add them. Number two is the quotient rule. The quotient rule, whenever you hear the word quotient, you are looking at division. The quotient rule, it states that if you have log m over n to base b, it's the same thing as saying log m to base b minus log m n, that's n to base b. See all these laws, they can go both ways. You can start from here and end here, or start from here and end here, because you will see practical examples. So you can go both ways. Don't be stereotyped that must be when you see this one, you get this one. Yes, of course, you can see this and you work to getting this because it's a law. And you can be at this point and you go back to this point. So it's vice versa. The third rule is the power rule. The power rule. The power rule. The power rule says that if you have log m raised to the power n to base b, then this one will come down and start, that is, it will start before log m to base b, like this. This one goes down, and I have it as n log m to base b, and vice versa. So this is the product, the power rule, that you have something raised to another thing. This is the power index or exponent. Understand? The power index or exponent will go down to become a normal number, and will multiply the number to the base of log of whatever you have. So the fourth rule is the change of base rule. So I believe you have gotten this one. You can pause the video and copy so that I can take off this and have the fourth rule. The fourth rule is the change of base formula. The change of base formula. Okay, so the change of formula number 4, I call it the change of base formula. Okay, here, if you have log of m to base b, for instance, you can now introduce another constant, commonly log 10 or exponents like this, log m to base k over log b to base k. So this one, you have changed the base. You have changed the base. This is the base it started from. But because you want to now change the base to a constant, this k is commonly 10 or exponent. 10 or exponent. Okay. So the fifth one is the logarithm of 1. What is the logarithm of 1? Logarithm of 1. Anytime you see log 1, log 1, log 1 to any base at all, log 1 to any base is 0. Why? Why? Because we know from indices that b raised to power 0 is equal to 1. We know from indices. So anything that this base will be raised to give you the log, the value. Understand? So raising any number to the power of 0 gives 1. That is why we have log 1 to base b, or any base, is 0. And another thing, logarithm of okay, we have done logarithm of 1. What about logarithm of the base? Logarithm of the base. That's what I was looking for. Logarithm of the base. That is, if you have log, but we'll be using b since, let us use b again. B to base b. So if you have b to base b, guess what it's going to give you? Can somebody guess? Okay, it's equals to 1. Why? Because anything raised to power 1 is that thing. So that is why we have it like that. So these are the laws of logarithm. Just like I told you in the laws of indices. Please just have these on your fingertips so that you can when you see questions, you can tackle it. You can tackle it. Okay, so I'll just quickly apply these laws randomly so that we can see how it is being applied. For example, if we are told to solve log or simplify log 125 to base 5, you see that this one is what we call the change of base formula. We can decide to come and say, you can use any method though, because this one now can go like this. Log 125 is actually 5 raised to the power 2. Sorry, 5 raised to the power 5. 5 times 5, 25. Sorry, 5 raised to the power 3. Yes. This one is 5 raised to the power 3 to base 5. So you know that when you have the one that the log 3, this one can come down and it becomes 3 log 5 to base 5. And you know that log 5 to base 5 is log of the base. You understand? Logarithm of the base. So it's 1. So you can say 3 times 1, which is equal to 3. This is the answer. You can use that one, or you can decide to use the change of base rule. But this one is straightforward. This one is very easy to use. You understand? Just split, change this one to the power. Express it as the power of its factor. So I've expressed it as the power of its factor, and this power here will come down. Remember, I told you one of the laws. This one will come down and become the coefficient of this, and you now have it as 3 log 5 to base 5. 5 to base 5 is actually 1. So 1 times 3 is 3. That can be done like that. Or you can use the change of base. Change of base. Log 125 to base 5 is the same thing as saying log 125 to base 10 over log 5 to base 10. You can do it that way. You can do it that way. And when you use your logarithm table, you get this one as 2.0969 over 0.69897. So when you do this division, it will give you 3. But I think this one is a better option. So for you to know how to apply the laws. Like I said, let the laws be in your fingertips. Have them in your fingertips so that anytime you can call it out and use for your calculations. Okay, let's go to further examples. If we have, these are from past questions that I'm bringing out now. If you are asked to simplify log 1.5 to base 10 plus log, okay, the question says 3 outside, 3 log 2 to base 10 minus log 0.3 to base 10. This is the expression to simplify. Make it simpler. Make it simpler. Simplification means that by the time you finish, it will become simple. Some people will simplify. After simplification, the thing will now be bigger than the question. The word simplify means make it simple. As they simplify to the lowest possible term, lowest possible to the point where you cannot go further in simplification. That's what simplifying means. All right. So this one we can just break it down. I can see I have 1.5 and 0.3. I can change all this one to fractions now. Change to fractions. Okay, so the fractional form of this one is the same thing as saying log. This one is the same thing as saying 15 over 10 to base 10. It's the same thing now. It's the same thing. Then I have here as, now this one I can go up. I can have it as the power. It can go up. So I have log 2 raised to the power 3. This one will go up. Like I said, that all these laws, you can do it from left to right or right to left. So that means you have to do it. This one will go up. Normally, there's the law that says that the power of the power law, and this one will come down. This one now is going up. Goes up and is set to base 10. Then minus log, this one is 3 over 10 to base 10. Now, here, in this one, I have everything in the same base. Log 10, log 10, log 10. Or log to base 10, log to base 10. So what I will do, I will apply product rule here and apply quotient rule here. This and this is times. This and this is division. I can even put the log outside and do my thing. See, each term have log 10, the same base. So I just say log to base 10 outside. Then I will apply product rule here. Where I see plus, I multiply. So it is 10 over 15 times 3 to the power 3 is 8 already. You understand? Then all over this division. All over, go and look at the laws again. I wrote to you. All over 3 over 10. So we are going to just do the maths for this one. This is just maths. This is just mathematics. Okay, so I can decide to do it like this. Log to base 10, open bracket like this. So 15 over 10 times 8 over 1 divided by. So if I'm dividing, this one will now invert. Divided by 10 over 3. This is it. This is it. From here, I can cancel now. 10 will cancel 10. What else do I have? 3 here 1, 3 here 5. So 5 times 8 is what? 40. That's 5 times 8. There's nothing here. Nothing here again. So it's just, the answer is log 40 to base 10. This is the simplification of this. So I've ended up turning this 1, 2, 3 terms in the expression into just a single term. That's my simplification. All right. I will take another past question. I'll just take this one off. Take it off. Okay. So if this one now is in an equation form, say if log 20 to base 5 is equals to x, find x. Find x. X is missing. Let's look for it. Let's get it back. And this is like equation. So what value of x do we have that this equation will be true? So the first thing we'll do is remember the law. Okay, this one now, this one can go up and raise this one up. You know, we said that whatever power, this one can be raised, you understand, to give this one, that is logarithm. So I can come here and say uh, 20 is equals to 5 raised to power x. This one and this one, they are the same thing. They're the same thing. They're the same thing. Okay. So at this point, I can take log 10 of both sides. This one is now change of base. I can take the log of 10 of both sides. Okay, so I can come here, take log 10 of both sides. Take log 10 of both sides. Okay, so whatever I do to this side, so this is log 20 to base 10 is equals to log 5 raised to the power x to base 10. Okay, so at this point, I can now decide to do the power law here, where this one will drop down. So I have it as, this side is still log 20 to base 10 is equals to, this one drops down, x times log 5 to base 10. So I'm looking for x. I'm looking for x. So what I will do here, I will divide both sides by log 5 to base 10. So log 20 to base 10 over log 5 to base 10 is equals to x. So when you do your calculator, you can find out what this is. X is now equals to 1.861 by punching the calculator. You just say log 20, because the log, that's log 20, that's log 20 divided by log 5. So it will give you 1.861. This is the answer. This is the answer. So we'll do one more example and we'll wrap up for this topic. Do one more example and we'll wrap up. Okay. So the last one here says evaluate 2 log 9 to base 3 times log 81 minus 2 to base 3 all over log 625 to base 5. Okay, so you take a deep breath. I'm seeing, well, one of the past questions, I'm seeing this minus here, and it's looking as if it's a big deal, but it is not a big deal. It is not a big deal. Just inspect it. What do you think we can do to this? The first thing you do is to try and break this to the powers. The power. So I will come here and still write this one 2, then log 9 can be expressed as 3 raised to the power 2. So I just put 3 raised to the power 2 to base 3. Just note how you are doing the subscript. Don't be carried away that you will now put 2 near 3 and it's 32 you are seeing when you continue. Sometimes you forget. That's why you write down. Mathematics is writing down steps. So when you're writing down steps, the annotations, make sure the annotation, the subscript, the superscript, the minus sign, everything, the cancellation and the small thing you're putting by the side, everything you put them clearly so that when you go to the next step, you will take off from where you are. So you represent this like this, the same thing. Okay, so times. The next one is this minus 81 here. Minus 81 minus raised to the power minus 2. Don't bother about it too much. Just take a deep breath. My base 3. Now 81 itself is what? Is 3 raised to the power 4. Because 9 times 9 is 81 and 9 is 3 times 3. So you have 4 3s inside 81. 4 3 factor 3 times inside 81. So it's 81 is now 3 raised to the power 4. 3 raised to the power 4. Then the minus 2. So you see that these two, they are in the same level though. Don't put this one on top again. They are in the same level. 4 and this is minus 2. They are the same level. So I still come down again and write log 652, take it. 652 is actually 5 times raised to power 5. That is 652 is 5 times 5 times 5 times 5 times 5. Okay, so I put base 5 here, then 5 to 5. 5 to 5 raised to power 5. All right. So at this point, um, we is this no? This is not 5 to 5. It's 4. See, let me do it this way. 6 to 5. 6 to 5. Please always trust your instinct to cross check. 5 times 5 times 5 times 5, because 25 times 25 is 625. Okay, so that's 5 raised to the power 4. Sorry about that. So 5 raised to the power 4. Always be careful, step by step. Okay. Okay. So the next thing we'll look at is uh, how to do this. This one can come down, can come down. When it comes down, this is the power rule. So I come down and make this one, it will be 2 times 2. So it's equals to, this 2 comes down. 2 times 2 log 3. Sorry, let me raise this. Oh, I need to split this into 2 so that I can wrap up. I will do this here and complete it here. Okay, so this is the same thing as 2 comes down. 2 times 2, then log 3 to the base 3 times. Okay, for this side, 4 times 2 is 8. That's minus 8. So minus 8 will come down. So minus 8 will come down. Let me put it like this so you know. Minus 8 will come down. I have log 3 to base 3. Okay, all over. Please, I want to be showing an example of how you should write very well so that you don't miss the steps. Don't miss the steps. Okay, so we are here now. Then all over log. This is now, this 4 will come down. 4 will come down. Then I have 5 to base 5. Now notice something. All these things now, look at this one now. There's a law that says 3 log the base to the base is 1. So this one is already 1. This one is 1, and this one is 1. So I come here. 2 times 2 is 4. Then times 1 minus, times minus 8 into 1, because this one is 1, all over 4 into 1. So from here, this one can cancel this one, and my final answer is minus 8. You see how we have come a long way from where we have this complex thing here with crazy negative power here. So you are actually combining many things. The indices, your knowledge of indices, basic laws of indices, and even logarithm, the laws of logarithm, to simplify this. So I will encourage you to study, to go through these laws. They are very important, and know how to apply them. Like I told you, always look at the laws as applying from left to right and right to left, vice versa. Do not just be stereotyped to say, oh, because it's written from left to right, then anytime you see what's on the left, what's on the right is what you use. Sometimes you will see the right, what's on the right of the laws, and it's the left you go back to. So please note that, and then do practice, and you'll be fine. So I hope this video has been informative for you. Please like, subscribe, and comment on our page, and share for people to know what we are doing. I want to thank you for viewing.